Welcome to Sacred Cow Shipyards, where no ship is safe from being taken down to its nuts and bolts. This topic and/or question came up on the Twitters a little while ago, and while we covered a lot of the topic back during our automatic bus transfer switch episode, I am going to cover pretty much some of the same information over again just so everyone has, the same information. We're all on the same page, whatever idioms you want to use. And the long and the short of it, and yes, I'm going to get to the point right now, how shocking, is how does Starfleet move energy around starships? Well, the succinct answer is it's insect fornicatingly wild! But I should give you some more context before we get to the absolute hilarity of it all. And to start with, your current warships, and in fact your freighters, and basically every other ship that you have floating on the oceans right now, be they nuclear or gas turbine powered or boiler or Kodag or whatever else you want to talk about, they all generate power the same basic way that like 95% of electricity is generated on your planet. Spinny, spinny thing, make sparky, sparky. That's what it all boils down to. And then that sparky, sparky gets to go somewhere else by some variation on a theme of copper wire. And yeah, y'all settled on this technology, I don't even know how long ago, and you've basically stuck with it, and here we are. Now, I am grossly oversimplifying, as I always do, because I only have so much time. In fairness, there are some other electrical generation plants that do not require spinny, spinny things to make sparky, sparky things. And there are ways of transmitting electricity. In fact, your absolute nutcase lunatic, who is totally not a nutcase or a lunatic in certain degrees, Nikola Tesla, was right. You can transmit electricity wirelessly. You're working on that. It's exciting. But warships do the tried and true of spinny, spinny, sparky, sparky, and here we are. And to give you a brief rundown of one particular warship, say the long-since expired, long-since decommissioned Oliver Hazard Perry class for the USA and Navy, although I understand a number of those ships were purchased by other navies and may still be in service, so maybe this information is still valid, although the details I am sure have changed significantly. Regardless, the Oliver Hazard Perry class was the smallest technical warfighter of the USA and Navy for quite some time. Technically, the minesweeps and a variety of tugs were also smaller, but minesweeps aren't really considered warfighters. They're not very well armed for that. However, despite being a fairly small vessel, that is to say she was only about 453 feet long in her longest form and displaced about 4,200 tons, give or take a little, she had 4 separate power generators on board. Now, technically, most of this was due to redundancy. Things break, things get shot, it's good to have spares. In a you're technically correct, which is the best kind of correct kind of way, the Oliver Hazard Perry class could technically run off of one of those 4 diesel generators. Life on board for the squishies would not be comfortable, mostly because the chill water plant would be cut off from the air handling system, and the desalination plants would be limited to potable water only, which basically means no air conditioning and salty showers. Depending on what part of the world you were in at the time and what season it was at the time, that could lead to a really uncomfortable existence. Ideally, the Perrys would operate on 2 to 3 diesel generators. She could strictly operate on 2 if she had to, but 3 was generally considered to be better just because you could balance a load more evenly across the generators and it involved less wear and tear on the actual machines, which is just as well because the stock Perrys came with an absolute tub of a diesel generator. That is to say, the Detroit Diesel 16 Victor 149 Tango India. Amusingly, the company behind that generator was actually based out of Detroit. You can never really tell with you Humies, but the basic premise of the designation was that it was a 16-cylinder V-style internal combustion engine where each cylinder had a displacement of 149 cubic inches or 2.4 liters. Yes, they're approximately the same size as your soda bottles. At least in some countries. Anyways, the TI stood for the fact that the engines were turbocharged with an intercooler. Make them more powerful, right? More air, more better. And in fact, thanks possibly to its square bore design, it was a remarkably powerful engine for its weight. However, it leaked like a sieve. It was definitely one of those many, many engines you Humies make, where if it's not leaking, you should be concerned. It took the concept of a wet sump literally. And in fact, since the particular 16V configuration had 2 blocks, 2 crankshafts bolted together, 2 blowers, and 4 turbos, it had a lot of moving parts that didn't get along very well, and it broke on a regular basis. It was so common for Perrys to be down to a single generator simply because of equipment malfunctions and just total breakages that the USA Navy, and basically every Navy who bought these after the USA Navy retired them, started replacing all the Detroit diesels with Caterpillars, which are much more reliable. And no, I'm not talking about the utterly horrifying organisms that mutate into the flappy things. I'm talking about the yellow and black industrial equipment company. That stuff. Anyways, that's the generator. Enough about the generator. Once the generators do the whole generator thing, they send their electricity to a adjacent switchboard. There were, in fact, 4 switchboards for each of the 4 generators. And each of those 4 switchboards would then distribute the power either to the area of the ship that it was responsible for, or also shunt some more load to the other switchboards. That way you could just run the ship off of 1 or 2 generators, because each switchboard would handle balancing the load between all the other switchboards. Naturally, there was a lot of human input into this process because the ship was quite old, and automated systems were not installed because the USA Navy was, cheap. Now, at this point, it is important to mention that the electricity is still not exactly what you expect in your wall outlets. In fact, the electricity being distributed is at 440 volts, 3-phase, and I believe 60 hertz still, but the information I have is quite outdated and I never came by it. Of course not. Moving on. But basically, the ships use 3-phase power because that makes getting other spinny things started easier. Yes, in fact, getting electric motors started with 3-phase power makes life so much simpler for the motor and the operators that basically all industrial machinery is run off of 3-phase power on your planet. Also, just as a fun little factoid, single-phase alternating current power requires 2 wires, the energized wire and the neutral wire to carry the electrons back, basically. 3-phase power doesn't require a neutral. So you pass 3 times as much power only using 1 more wire, assuming all the wires are the same, blah, 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 so on and so forth. Still an interesting detail. And then, conveniently, when you want to go down to a 1-phase system, like what you expect in your wall outlet, you just peel off one of the wires of the 3 wires, you step it down because the voltage is still much higher than you expect at your wall outlet, and then you supply a neutral wire, a ground. Well, good news, you're on a ship. Big metal box. In the ocean. Guess where the nearest ground is? Again, massively oversimplifying, but the transformers and phase control systems on warships are pretty straightforward and simple. The 440-volt system, less straightforward and simple. I'm aware of at least one story where a electrician's mate, an EM, I believe he was a seaman, although my information again is very out of date, and you know how my old memory banks are. But anyways, he was tasked with securing the shore power connection on the ship after the ship had gotten underway. And yes, when ships pull into port, they plug into massive extension cords, approximately the diameter of an average human leg, and they turn off their generators and rely on the shore power grid. Well, once you unplug, you have to do some basic maintenance and clean up and so on and so forth, and put everything away, basically, and this seaman was tasked with that particular job, and neglected to ground something in the process. Well, the connection between the shore power system and the switchboard had thankfully been severed, but there was enough capacitance left in all the equipment between there and there that he quite literally got knocked on his ass. Warships don't mess around when they're moving power around. But that brings me to the last interesting detail about how Humies move power, depending on how you look at it, around. Because yeah, the generators, the switchboards, the electrical distribution system on board the ship, all of that is still fundamentally copper wires. And it's all generated by spinny things, and it's moving sparky things around, and it's no big deal. It's basically what you understand if you have looked at all at your power grid and how when you plug something into the wall, the light turns on. But have you ever considered how radar works? Yes, I know, it's radio detection and ranging, but the big spinny thing, the thing that makes the bleeps, the sweeps, and the creeps, do you think it generates all of its radar energy up there on the emitter? Maybe? Do you? I don't know. If you do, you're about to be one of the 10,000 at least people every day who get to learn something new. And learning is always a good thing. But the short answer to my question is no. The emitter does not actually generate the radar waves. Now, that's only mostly applicable for military radar. Civilian radar like Furuno and stuff like that, they do their own thing. Ignore what I'm saying with regards to them. But for military radar, specifically again for the Perry-class warships, the radar energy is actually generated a deck beneath the mast. And the radar emitter for, let's say, the Alpha November / Sierra Papa Sierra TAC 49, which is a positively horrible air search radar, but whatever, was about halfway up that mast. Well, I mean, technically it was on its own little tiny mast in front of the main mast, but you get what I'm saying. So if the radio energy was generated way beneath the radar dish, how does it get from A to B? Well, you Humies have come up with this absolutely marvelous concept called a waveguide, which, when you get right down to it, is a really nice complicated word for a box-shaped pipe. Specifically a metal box-shaped pipe, but mostly just a box-shaped pipe. Again, not even joking. Again, massively oversimplifying, but that's basically what it boils down to. Now, there's massive amounts of physics and all kinds of weird mathematical equations and details and combinations and complications and this, that, and the other to go into the basic premise of how a waveguide can take radar energy, radio energy from an emitter and move it all the way up to the actual emitter that's bouncing that radio energy off the dish and off into the void. But suffice to say that this really weird metal box can route that energy from A to B seamlessly. You won't hardly even know it's there, aside from the fact that they're mostly not painted, which is highly unusual on most USA and Navy warships. And now, just to put this again in a certain degree of context for you to understand, going back to that SPAS 49, and yes, the SBS designation is frequently shortened in the USA Navy to SPAS, which, yes, is quite amusing. The SPAS 49 has a power output of about 13 kilowatts on average and about 360 kilowatts at peak. And this strange pipe, which probably has the internal dimensions of approximately a USA and currency bill, is able to route that 360 kilowatts of energy from the generator all the way up to the emitter. Yeah. How crazy is that? You're moving the energy output of 360 microwaves, the cooking appliances, through a space the size of your hand. And it's a hollow tube. Yeah. Nuts. But there's a reason that I chose waveguides as a segue to the topic of like I said, the original topic that it has taken us, 12 minutes to get to. And that is to say, how does Star Trek power their ships? Or more specifically, how does Starfleet power their ships? Anyways, this basic concept does apply to multiple ships. We're just not sure how many species actually use it. It's widespread, just not universal. How about that? Anyways, the primary power distribution system on basically every Starfleet ship ever is called the electro-plasma distribution network. Now, that is the term preferred by the engineers. The name that pretty much everyone knows it by is the electro-plasma system, or EPS, more commonly referred to mostly as EPS conduits, although that refers specifically to the actual conduits that the EP moves through, but you get the idea. Now, why did I think waveguides were a good segue? Because, well, you're moving plasma through a tube. Now, radar energy isn't actually plasma, obviously, but still, you're moving highly energetic something through a hollow metal. Okay, fine. It's not a great segue. I thought it was better than copper wires for fornication's sake. Mostly because EPS conduits can actually be, approximately simulated by copper tubing, as long as they're reinforced with a nanopolymer, whatever the hell that is. So, I mean, it's still a hollow tube carrying energy through it. Come on, work with me here. So, anyways, what is electro-plasma? Well, it's obviously special plasma. But you want to know the real kicker, the real joke of this entire conversation, the absolutely wild part of all of this? Electroplasma is the same thing as what you know of as warp plasma. Yeah, you heard that right. So, on basically every Starfleet vessel, there is somewhere a warp core, correct? Possibly, mostly. It varies wildly. We're going to assume there's a warp core. And this warp core, technically all it is, sort of, kind of, is a matter annihilation engine. It takes matter, it takes antimatter, it annihilates the two, and behold, E equals mc squared times 2, and it focuses all that energy through the dilithium crystal matrix, I think. Star Trek kind of makes it up as it goes. And focusing all that energy, it creates or energizes or does something with electroplasma. And behold, that's the power system for basically every Starfleet ship. And yes, from the warp core, there are as many large conduits of EPS going to the warp nacelles as there are warp nacelles. Mostly there are 2. Sometimes there's 1. Sometimes there's 3. Sometimes there's 4. Star Trek can't keep to its own rules. Fine, whatever. But the point is that, yes, the same energy or energetic material or energy transfer system or whatever you want to call it that powers the actual systems that generate the warp bubbles around starships also powers your local replicator. It's just a matter of the scale of the pipe and the amount of EP, electro-plasma, that you're using. Obviously, the warp drives in the warp nacelles are consuming a massive amount of that plasma. Or, I don't know, is it consumed? Is it lost? Do you make more plasma, or does it route back by way of like a neutral line, like one-phase power? I have no idea. Like I said, Star Trek kind of makes it up as it goes. But regardless, the conduits going to the warp nacelles are chunky. The conduit going to, say, the holodeck probably isn't that big. And this is where it gets even weirder. Because yes, you're routing massive amounts of plasma to a warp nacelle. You want to keep track of the temperature and the volume and stuff going on there, right? Yeah. So of course you have plasma coolant ducts, which of course, Star Trek being Star Trek, break a lot. There are also plasma conversion sensors. It's unclear what those do. Do they keep track of how much plasma the warp drive has created, or how much plasma has been converted entirely into energy in the warp nacelles? That might answer whether or not there's a neutral line for the EPS grid, I guess. Possibly. I don't know. Again, Star Trek. More magic than not. And then, of course, since plasma kind of operates like a liquid, sort of, under certain conditions, there are plasma distribution manifolds, which do exactly what you think they would do. They are a manifold that distributes electro-plasma wherever it needs to go. And every time I say electro-plasma, I think of Ghostbusters for some reason, so now I'm just having this weird crossover in my processors, and wow, we're not even going to get into that. And then yes, of course, electro-plasma can be bled off into, aptly named warp plasma canisters, or possibly even a plasma infuser for mobile use as basically a very large battery. Or bomb. Mostly battery. But then isn't every battery a bomb if you use it wrong? Thoughts? But anyway, sorry, I'm getting distracted as I always do. The really interesting thing is the existence of something called an EPS tap. Now, me, personally, as the great and almighty Dockmaster, I would consider that EPS taps are where you fill said aforementioned warp plasma canisters or plasma infusers. Apparently they're not. No beer for you. Instead, they are where the electroplasma gets stepped down to just electricity. Huh. So Starfleet does run something somewhere on just plain simple old electricity. I wonder what. I mean, like the lighting, sure, but like replicators. They are technically reforming matter by using a whole pile of energy to do it. Are they really running massive trunks of electricity to the replicators, or are they running little tiny EPS conduits to them? Which brings us to the fun conversation / question / problem. You know how every single control console everywhere in every single Starfleet vessel seems to be made out of explodium? Well, the simple answer to that question, implied question, whatever, is yeah. There's a little tiny EPS conduit behind the console, powering the console. And yeah, it ruptured. And guess what plasma does when it's exposed to a non-confined, non-controlled environment? It goes boom! I mean, y'all should be thankful that the EPS grid on Starfleet vessels are so tightly valved, so tightly controlled, that it's not a continuous boom. There's a boom, and then apparently the EPS conduit going to the console shuts off, and thankfully there's no more big boom. But yeah, what? They were possibly, potentially, maybe running literal plasma behind the control panels that people were using to control the starships? And then they were suddenly surprised when said control panels blew up in their faces? This seems like the start of one of those, what's the term? Cultural reference points. I gotta find it. Hold on. Yes. The ambulance chasers on your planet do. Has the Starfleet Department of Veteran Affairs decided that your console exploding in your face because an EPS conduit behind it ruptured was not a service-related injury? We can help you. Call 123-45-QUARK on the Interstellar Communication System. This advertisement was totally not paid for by the Sacred Cow Shipyards and has absolutely nothing to do with Sacred Cow Shipyards, and I don't even know if that number even exists. So I don't even know why I'm doing this, but it seemed funny at the time. I mean, realistically, most of what I do is because it was funny at the time, so why would I do anything different right now? Come on. And that's all from Sacred Cow Shipyards. Please be advised that any ship left on the docks for more than 24 hours will be compressed to a cube at the owner's expense. Have a nice day.